All right, Palatine chemistry. Let's talk about solubility. We're going to talk about a couple main aspects of it. We are going to talk about the what, the why, and the how. Okay, what is it? Why does it happen? And not only how does it happen, but how can we predict if it's going to happen or not? So, real simple, the what is when something dissolves in water. That's solubility. Okay? Pretty simple, the idea behind it. It dissolves. An aqueous solution. Aqueous is a word you're going to come across, meaning just in water. So now water is really important because it's polar. Okay, polar, like poles of a magnet, has a positive, has a negative. So this is the structure we're looking at here. That's our friend, good old dihydrogen monoxide. So now how that actually works is when you have, this is our friend salt, NaCl. We've talked about him a lot. And we have water. They're going to interact. Okay. Now, to help show this, here's a quick video. Should be quick. Our friend, the water molecule, comes in contact with a very large crystalline structure of salt, NaCl. And it's going to go through, it's going to talk about the structure of the water. It's going to talk about how it has positive side and a negative side. So it's polar charges. We're going to get into how to determine that and everything. However, you just need to know it has a more positive side and a more negative side. And in the salt structure, you have the sodium ions, which are positive, chlorine ions, which are negative. I understand that they gave those up, and now they're in the big structure. But those water molecules come in. They surround the negative chlorine atoms with the positive side of the water, and conversely, they surround the positive sodium particles with their negative sides. Okay, and so then this is the structure that you're going to look at. You're going to have those opposite charges surrounding them in that structure. Okay, so that's physically how it actually works. You get these little water molecules. They come in and they dissociate, break apart, dissolve, whatever you want to say, the crystalline structure of salt. Now, this doesn't happen with all structures. In A, we're talking about just ionic structures. B, this doesn't happen with all structures because some structures are too strong and they can't be broken apart. Okay. Now, again, I did mention this term before, and I should come back to it. Aqueous solution dissolved in water. Okay, that's a key term. Test question. Test question. What does aqueous mean? Dissolved in water. So, the what? We are simply talking about dissolving an ionic compound in water. The why, okay, as we kind of just looked at, was this video as far as you have water molecules which are polar surrounding the ionic compounds and dissociating it into its ions, okay? How, and most importantly, how are we going to identify it? Goes, oh my gosh, look at this. What are we talking about? All right, this is a lab that we're going to do, or you're going to look at, or you're going to see. And not to spoil it, but you don't have to do this lab at all. Put yourself into an assessment situation in which we're going to ask you this question. We're going to give you these solids or their formulas, and then we're simply going to ask you, will this be soluble in water? Will it dissolve in water? And you're going to have to look at these and identify, will that happen? Okay? So at this point, you've been able to create, write, name, identify these structures, and you did that because you knew about their charges, okay? And that's not going away. We're going to be bouncing between our periodic table, and I'll start with a simple one, okay? Ooh, got some of my old notes on here. Whoops, get those out of here. If you watched my lecture on ionic basics, I thank you. You're the one person that watched it. So now we move on to this. Let's clean this up here. And I want to start with a simple one. Let's start with calcium chloride. Okay? And again, will calcium chloride be soluble in water? You're not going to have the chemical during the test. You're going to need to know, will this actually happen? So I find calcium, just like I've been doing for a lot of my sample problems here. I find calcium, and I identify that it's going to want to be a +2. Okay, +2. I'm going to write it right there. And it's chloride right here. And it likes to be a -1. Okay, close that off. -1. Okay, so I have a +2 and a -1. Very simple rule. Okay, the rule is if it has a +1 and or a -1, it will be soluble. Okay. That's it. If it has a +1 or a -1, it will be soluble. Why? Because it's very weak. Okay. +1s, as we've discussed, are the weakest of the charge. +3s are the strongest of the charge. If it has a +1 in there, it's very weak. That water molecule is going to be able to come in there and break it up. Okay, because water is stronger. So, since this has a -1, yes, this will be soluble. Okay? That's all I have to do with these structures. I simply look at these structures. You know what? Let me stick with let's look at like potassium bromide. I go to my periodic table. I'll do some of the others in a second, but I'm just going to show you this one. So I'll go to potassium bromide, find potassium. Okay, if you haven't picked up yet, you're going to be doing this all of the time. You're going to need to find the elements and their charge. So potassium is a +1. I go over, I find bromide. Now, I can look at these very quickly because I also remember that ionic compounds are made of a metal and a nonmetal, a left and a right, a cation, meow, and an anion. So as soon as I find the cation on the left-hand side, I know that my next one has to be an anion, and I'm looking over here on the right-hand side. That's how I can find them so quickly. So I find bromine, and it's a -1. And I ask myself, does it have a 1 in it? Because if it has a 1, plus and or negative, if there's just one in there, it's going to dissolve. And by George, it does. It's got 2 of them, so it's really going to dissolve. And this is the one I'm looking at here. So yes, a little smaller pen, this will be soluble. Okay. Let's look at something like, I don't know. Let's look at calcium carbonate down here at the bottom. Okay, so same deal. Get my periodic table, get that on the left-hand side. I look for my cation because my cation is always going to be written first. And now I'm looking at calcium. Calcium is right here, +2. And carbonate. Now, carbonate, ATE ending. Hopefully we remember that. That tells me that I'm going to be looking at my ion list. ATE and ITE endings. And I'm going to find carbonate all the way up here. In carbonate, I see that it has a -2 charge to it. Okay. So I have a +2 and a -2. Well, my rule is pretty simple. If it has a plus or -1, it will be soluble. This one does not. Okay? This one does not have a 1. So if it doesn't have a 1, it's a strong enough charge. This will be insoluble. Which one? Sorry, guys. So it'll be insoluble in water. It will not dissolve in water. So pretty simple. If it has a plus or -1, it will be soluble. Why? Because if it has a plus or -1, it's very weak. and then I can have that water come in and break it apart. Okay, and if it does not have a plus or minus 1, if it does not have it, it's insoluble because it's very strong. So these are just pictures, same deal. These are just the interactions between them. But the big picture is you're just going to have to go through and be able to find these, just like we did. Identify your cation, identify your anion, find the charge. If your charge has a 1 anywhere in it, these have 1s, that's a 1, that's a 1, that's a 1, that's a 1. Anywhere that I have a 1, it's soluble. Okay, here's a 1 right there, soluble. Okay, so all these are soluble. If I have 1s, they're soluble. If I do not have any 1s, notice all these. I don't have any 1s here. No 1s. Okay, so if I have a 1, it's soluble. If I don't have a 1, it's not soluble. One question I get all the time, well, so do both of them have to be 1? No, only one of them has to be 1. Okay, so quick review all the way back up here to our initial chart. Pretty simple, plus or minus 1, it's soluble. And if it's soluble, that means that it had a very weak intermolecular force.